Hello, YouTube. I believe most people around the globe did not pay attention to this event, and it was so since it was not reported until much later. Let me present the Russian information first, then we'll get into Western data. On December 19, in the year 2018, at 2 hours 48 minutes Moscow time, a meteorite that invaded the Earth's atmosphere exploded over the Bering Sea at a 350-kilometer distance from the shores of the Kamchatka Peninsula. The fall of such a large object came as a surprise to scientists, since no ground-based telescope signaled to them that a celestial body was rapidly approaching the planet. So how did they find out that a powerful explosion occurred in the northern part of the Pacific Ocean? Well, it became known only after this object came into the field of view of the Earth remote sensing satellites, Terra, owned by the American Space Agency NASA, and Himawari 8, launched by Japanese specialists. The first of them triggered an infrared sensor that transmitted information to the military, and the second, taking pictures every 10 minutes, provided the public with a time lapse, that is, a video collected from a series of photographs, which perfectly shows the yellow smoke trail from the meteorite explosion and its long shadow, which changed its direction during the day. A space visitor with a diameter of approximately 10 meters broke apart at the altitude of 25.6 kilometers from the Earth's surface, piercing the atmosphere along a steep trajectory of 7 degrees at the speed of 32 kilometers per second. According to the Russian astronomer Denis Denisenko, this celestial object most likely belonged to the Earth's meteor shower, which was active in the designated area at that time. According to the information received from NASA, the explosion power of this meteorite exceeded the energy released during the atomic bombing of the city of Hiroshima by 10 times, and amounted to 173 kilotons of TNT equivalent. The NASA scientist dealing with the protection of the Earth from extraterrestrial objects, Lindley Johnson, stated that the explosions of this range occur only 2 or 3 times in a century. In the 21st century, there has already been a fall of a superbolide, to which the scientists have given the name Chelyabinsk. This event occurred over the Chelyabinsk region of Russia in February 2013, but then the explosion power of the celestial body was a record 440 kilotons in TNT equivalent. I urge you to watch my video about this very mysterious event, this Chelyabinsk celestial body, because what we're being told is not what actually had occurred. And I present information obtained from open sources in Russia and a few other neighboring states, but what we think happened, I don't think it happened. But anyway, the head of the Near-Earth Object Observation Program at NASA, Califast, said that when a meteorite exploded over the Bering Sea, only 40% of the energy scale that was recorded during the explosion of its Chelyabinsk counterpart was released. Or maybe it was a comet. Well, the Russian astronomer Stanislav Korotkий, having studied the images received from satellites, claims that the fallen space object is not a meteorite, but a fragment of a comet that moves in a highly elliptical orbit. This, in his opinion, is indicated by the almost vertical angle of the trajectory of the fall of the celestial body and its strikingly high rate of entry into the atmosphere. Scientists claim that it was possible to avoid the monstrous consequences of the shock wave resulting from the explosion of the meteorite only because its epicenter was located over deserted water area. It was also hit by fragments that broke off during the movement of the space object, which, when falling on populated areas, could cause damage to buildings and people. American expert Lindley Johnson calls the fact that the meteorite, by luck and chance, did not collide with any commercial aircraft flying at that moment between Asia and North America. Olga Popova, a senior researcher at the Institute of Geosphere Dynamics of the Russian Academy of Sciences, believes that ground-based telescopes overlook the approach of such a large meteorite due to the bad weather that set in those December days in the Far East. Among the factors that prevented the registration of the superbolide, its considerable distance from the Earth, it was listed, caused by the passage of the cyclone, extensive dense clouds, and daylight hours when the sun was 9 degrees above the horizon. According to her, if the weather situation in the region was good, the meteorite fall would have been noticed not only by ground-based observation, but also by the residents of the coastal settlements of Kamchatka, as well as the Western Aleutian and the Commodore Islands. So why was this silence, and how do we prevent similar situations? Well, this cannot but cause bewilderment due to the fact that information about the super explosion of this meteorite over the Bering Sea became public only 3 months later after the incident. According to Olga Popova, all this time, the U.S. military, who were studying data from missile attack warning satellites, were convinced that the explosion had a celestial origin and was not the result of the use of weapons by Russia or North Korea. To prevent the occurrence of such force majeure situations, when adverse weather conditions can cause the death of thousands of people from an unexpected meteorite fall, scientists propose to promptly combine data obtained from ground-based telescopes and orbiting satellites. But let's look now at some Western coverage of this event. As spotted, among others, by Meteor researcher Peter Brown of the University of Western Ontario, a fireball was noticed over the Bering Sea near Russia's Kamchatka Peninsula on December 18, 2018. The location was too remote for anyone on the ground to spot the fireball, but in this case, monitoring stations spread across the world recorded the impact. Apparently, the boom was picked up on the infrasound detectors, which have an ear for sound waves that humans cannot pick up. Using data from a myriad of satellites and sensors, NASA continuously updates its records of cometary and asteroid fragments that enter our atmosphere on its Near-Earth Object website. A quick browse of the catalog reveals that not insignificant chunks of space debris combust in our skies very frequently. But it's also fair to say that the event on December 18 stands out. Now, I must add that NASA has missed asteroids that were approaching our planets on occasions, but what can you do? The object was moving at the speed of 115,200 kilometers per hour, 71,600 miles per hour, and was obliterated, at the height of 26 kilometers. I think it's like 16 miles. This explosion unleashed the equivalent of 173 kilotons of TNT, which, as has been cited plenty of times by other outlets, is about 10 times the energy unleashed during the Hiroshima nuclear bombing. And the BBC, for example, stated that it released 40% of the energy involved during the Chelyabinsk meteorite explosion. So that's another confirmation. And per the New Scientist, this was the third largest meteor event in modern times, second to the Chelyabinsk and the 1908 Tunguska events. And the latter, which flattened tens of millions of Siberian trees over an area, I think you could put almost 3 New York City size cities there inside. But I urge you to watch my videos about the Tunguska event to understand the hypothesis presented, including the shoot down of an alien spaceship. Look also at the Yakutia videos I have. So, was that a meteor, or a meteorite in December of 2018? As the object made it through the atmosphere, but didn't impact the surface. This is known as a meteor. It's only a meteorite if it slams into the ground. At the same time, this was a fireball, as it was an exceptionally bright meteor, and a bolide, as it was a fireball that exploded in our atmosphere. Why did it explode in mid-air? Airburst events are fairly common for meteors over a certain size, moving at just the right angle and with the right momentum. Essentially, if enough air gets in front of a speedy space rock, this air becomes incredibly compressed, which heats it up. This causes the outer layers of the meteor to ignite, creating a fireball. As the pressure on the front edge of the meteor builds to a critical point, the mechanical strength of the rock is overcome. It rapidly breaks up, releasing a huge amount of kinetic energy as it does so. The meteor must be of a certain size for this violent fragmentation to take place. If it's too large, it may still burn up a little, but it will resist the urge to shatter. If it's far too small, it will simply be obliterated in the upper atmosphere. In this case, the Bering Sea fireball was, according to the scientist Brown, just 10 meters or 33 feet across, although it did weigh about 1,400 tons. Why do powerful meteor airbursts keep taking place over or near the territory of the Russian Federation? Well, it's just a coincidence according to Western media. Russia is the world's largest country by far in terms of area, covering 17.1 million square kilometers or 6.6 million square miles. There's a good chance that with all the other things being equal, meteors and space debris are going to fall over Russia at a greater frequency compared to other parts of our planet. Saying that, by the way, even Russia makes only 3.3% of the entire planet's surface area. You know, most of the Earth is water, consists of water, which is why most space debris explodes over or ends up in the oceans. Just like the December fireball over the Bering Sea. And it was close to Russia, by the way. So, did any satellite see the meteor other than the infrared trail? It looks like the Himawari 8 recorded the smoke trail over the over the Bering Sea meteor created as it began to burn up in our atmosphere. The smoke trail is pretty much perpendicular to Earth's surface, which matches with the NASA's data, showing that the object entered the atmosphere at a steep 7-degree angle. How commonplace are meteors like this? Space debris hits Earth's atmosphere and the lunar surface pretty much all the time. However, for impacts of this energy output, they occur somewhere on the planet once every few decades. As it happens, a recent study indicates that from about 290 million years ago, the number of impacts both on the moon and Earth tripled compared to the 710 million years prior. And there is no sign that this bombardment has slowed down as yet. It is not clear why this happened, but a cascade of destructive events in the asteroid belt could be to blame. Is this fireball a descendant of that ancient cataclysm? It's hard to know, but it's certainly safe to say that our planet serves as target practice for the rocky remains of the inner solar system. So should we worry about this type of meteorite or meteor? Well, the space debris of a certain size crossing our planet's path is something various space agencies are, of course, very concerned about. NASA has its very own Planetary Defense Coordination Office, for example, and it's tracking the sky, hoping to spot a range of potentially hazardous objects that will come within 8 million kilometers, or 5 million miles, of Earth orbit, which, by the way, is close by astronomical standards. In general, the office tracks objects that are at least 30 meters, about 100 feet across, which at that size will cause significant damage if they impact our planet. The Bering Sea event, although very energetic, was about a third of that size. The Chelyabinsk meteor was about 2/3. Technically, neither would make the cut, even though, as we can see, in the case of the latter, it can cause plenty of injuries, even by exploding in mid-air. That's not because NASA isn't concerned about them, but because they are far harder to spot, according to NASA. Those 3-meter-long objects, by the way, aren't enough to cause planetary devastation, according to some scientists. The Chicxulub impactor that hurled at the end of the age of the dinosaurs, for example, was 12.1 kilometers, or 7.5 miles across. The 30-meter-long city killers are the most dangerous celestial guests. This includes the next Tunguska, a 60 to 100 meter, 200 to 330 foot rocky meteor. That's, again, what some interpret the event to be. Like Chelyabinsk before it, the Bering Sea meteor is a timely reminder that we need to do all we can to keep our eyes on the skies. After all, they're not going to explode above or slam into the ocean all the time. And of course, they could cause major damage to a populated area. So back in the late 2018, Earth dodged a bullet. Well, almost, because a hefty space rock streaked through the upper atmosphere, detonating with the power of a nuclear bomb over that isolated stretch of the Bering Sea between Russia and Alaska. But this information was concealed for months. Do ask yourself why. And remember, 110 years before this event, the Tunguska event occurred. And 1 year later, another interesting event took place. The U.S. Space Force was established on December 20th, 2019, when the National Defense Authorization Act was signed into law with bipartisan support, creating the first new branch of the armed services in 73 years. The establishment of the United States Space Force resulted from the widespread recognition that space was a national security imperative. When combined with the growing threat posed by near-peer competitors in space, it became clear that there was a need for a military service focused solely on pursuing superiority in the space domain. That's the official explanation. But is there a connection of some sort with the event 1 year prior? I do not know. But I have presented information about the Russian space forces that go back decades, of course, back to the Soviet times. They monitor the near Earth orbit and various objects there quite diligently. And I urge you again, you can find videos about it in my channel. So that's what I wanted to let you know about the events of December 2018. I don't expect we're going to find anything more than what I told you anytime soon. And I'll bring you more interesting stories about the developments in the near orbit and the way Russia and China and the United States, how they operate and what they see based on open sources. So that's my presentation today. If you like my research, please support me through the links you'll find in the description of this video. Please like my videos and please tell others about my channel and subscribe. Thank you.